Hey guys, today we're going to move actually to a new lesson, and we're going to take a couple sets of notes from this guy, and then we'll get wrapped up and get ready to take a test. I know, you're like, but we just took a quiz. I don't know, life goes on. So today we're going to talk about something called literal equations. So this is, you actually know what a literal equation is, but you just haven't heard it called that before. So literal equation is also, so AKA, also known as a formula. So it's an equation that involves several variables. Okay, and basically the reason why it's literal is that you can't actually solve it, but it meets the condition of an equation where you have variables and numbers and operations and an equal sign, so on and so forth. So, but the reality is, the reason why we studied the literal equations is that sometimes, like for example, you learned about area is equal to length times width, and for years you were given the length and the width and you just calculated the area. Well, then as you got a little bit older, you were given the area and the length, and your job was to figure out the width. You just practiced that on a worksheet not too long ago. So what we're going to talk about in this lesson is how do we actually solve a formula, a literal equation, for a different variable. So to solve a literal equation, and for whatever reason, kids are pretty much understand the whole how do I get x alone, but when you've got an x, a y, a z, and a w all together, how do you do math with variables? You're going to find out it's really not that much different from doing it like a normal equation, okay? So to solve a literal equation, you are going to isolate the variable, the given variable, to solve for, and that's going to be given to you in the instructions. Okay, so just like we would in a normal equation, we would use inverse operations. Okay, so that's basically what's going to inverse operations. Okay, so let's do some examples. So we're going to solve for the given variable. And we've got about a handful of these to do. So we get 15 equals 3n plus 6p. So this equation has two variables, and then you'll see a comma, and then it'll say 4, and then it's going to tell you what variable it wants you to get alone. So I'm going to just highlight that variable. So they want n to be by itself. So what you're going to do is we're going to get rid of the 6p. So the opposite of adding is subtracting. That's going to give me 15 minus 6p equals 3n. So I'm going to go ahead and use the symmetric property of equality and flip what's on each side. Now when I say flip, that's pick up and take over. It's not like turn around. And then we want to get it to be n by itself, so we're going to divide opposite of multiplying by 3, we're going to divide everything by 3. So we get n equals 15 minus, 5 minus 2p, okay? And that's it. That's all we're doing on these, okay? Let's do another one. Let's say we have k minus 2 divided by 5 equals 11j, and we want to solve for k. So one of the things that's a problem is we've got a fraction on one side and a whole number on the other. So what we're going to do is get rid of the fraction. We're going to clear the fractions. So we're going to multiply both sides by 5 because k is what we need to get alone. So when we do that, 5 divided by 5, I get k minus 2 equals 55j. And then I go ahead and add 2. Inverse of subtracting 2 would be adding 2 to both sides. And we get k equals 55j plus 2. Okay. Number 3. We've got a times the quantity q minus 8 equals 23, and then we're going to solve for q. So again, I'm going to highlight what we want to get alone. So we have a couple of options here, and I'm going to share with you what I think is, well, I may even show you 2 different strategies on this one. So one way is, let's just distribute and get rid of the parentheses. So we're going to distribute a, and we're going to get a times q is aq, and then we distribute the a to negative 8, and that's going to give me negative 8a, and that still equals 23. So remember, what I'm trying to do is to get q alone, so I'm going to highlight it again. Come on, you. There we go. So again, we're going to do adding or subtracting first. So the inverse of subtracting 8a is adding 8a. Now for me, if my a, or my variable is a positive one, I like to put the a in front. It's always kind of my habit, and have the constant at the end. But remember, I want to get q all by itself, and we still have it being multiplied by a. So we're going to do the inverse of multiplying by a, and we're going to divide everything by a. So that gives me q equals 8 plus 23 over a. So now that ended up over there. Crazy, huh? Alright, so I'm going to show you a secondary way I would have solved this. And I'll just do it over here. So we have q minus 8 equals 23. So instead of distributing first, what if I divided first by that factor out in front? What if I divided both sides by a? Well, that would give me, q minus 8 equals 23 over a. And then I would just add 8 to both sides to get the q by itself. And that would give me q equals 23a plus 8. So either one of those would work just fine. So kind of whatever feels more comfortable. I'm going to go to my next screen. You should still be on the same page. And let's do number 4. Got 3 more. So I have d plus 5c equals 3d minus 1, and we want to get d by itself. So first thing I need to do is I need to get all the d's together. So I'm going to subtract the inverse of a positive 3d is a negative 3D, so I'm going to subtract. That gives me negative 2D plus 5C equals negative 1. And then, again, my goal is to get D by itself. So, inverse operations, we're going to subtract 5C from both sides. So that gives me negative 2D equals negative 5C minus 1. And then my last step would be to do inverse operations, and we're going to divide everything by negative 2. So that's going to give me D is equal to 5C over 2 plus 1/2. And I can also write this, I'm going to keep this as fine, you don't have to get much too fancy, but sometimes what people like to do is if my coefficient, there's a number in the numerator and the denominator, you can pull out that fraction that's created, 5/2, and put the C next to the fraction bar, so it's 5/2 C plus the 1/2. So either one of those would be fine. And then we have 6Q minus 18, oops, it's supposed to be 18, equals QR plus T, and then we want to solve it for Q. So this is where it gets tricky. It wants me to get Q by itself. I'm multiplying. In both cases, there is a coefficient in a way. One case it's a 6, the other case it's a variable r. So first things first, let's just get whatever is like next to each other. So let's go ahead and subtract QR from both sides. Sorry, try that again. QR, thank you very much. And that gives me negative, sorry, I like to put the positive in front, 6Q, oh my goodness, minus QR minus 18 is equal to T. And you're like, well, that's kind of cool, you got T all alone, but that's not what it asks you to do. So I can go ahead and get the 18 on the other side by adding it to both sides, inverse operations. And now here, I need to somehow figure out how to get something that shows up in two places to only show up in once. And that's when we need to remember our friend, the distributive property. Because the distributive property allows me to factor out a common factor. And since I want to get Q alone, if I can get it to show up only once, then I could eventually get it alone. So 6Q divided by Q is 6, minus QR divided by Q is R. So then the last thing I'm going to need to do is to divide both sides by that quantity, 6 minus R. And we get Q is equal to 2 plus 18 over 6 minus R. Now, I know you guys are going to be tempted to want to reduce the 18 and the 6, but you cannot reduce things that are part of a polynomial. And a polynomial is when you take monomials or terms and you add them or subtract them. So you can't take pieces apart. You can only take out factors, okay? So this is actually as far as you could go on this problem. All right, I got one more for you. So this one is dealing with the formula, and you're going to have to write this down. So actually, I'm going to pause this, write it, and then come back again. So I suggest that you also pause it and write it down. The formula for a volume of a rectangular prism is V equals LWH. And that means length, L times W times H, where L is the length, W is the width, and H is the height. Solve for the width. So this is exactly what I was talking about in the beginning of the notes, is where you have a formula, and in the past, you were told the length, you were told the width, you were told the height. You did that in 5th and 6th grade. And then you were told to calculate the volume. And now, as you get a little bit older, now you get the volume and 2 of the other dimensions, and then your job is to figure out the missing dimension. So in this particular case, we want to figure out what the width is. So we're going to get width alone. So let's think about this. The inverse of multiplying length with width and height with width would be divide. And I can take care of them at the same time. So I'm going to divide both sides by length and height. Now if I do that, I get V equals LH, L divided by, try that again, B divided by LH equals W. Now, we got to use the symmetric property because we're solving for the width, so the width variable has to come first. So we get W equals V, which stands for volume, divided by L times H, which is length times width. And that's all I got for you guys. All right, have a good one. See you later. Bye.